our office up on UAF, uh, up at our office on UAF West Ridge. And then Ed will take us through some of the forecast challenges that we face. Then me and Ed will just kind of flip flop back and forth. I'll go through some online data sources that could be of use when planning trips. Then we'll kind of go through an outlook for the winter 2020 through 2021. We'll discuss some typical weather patterns for interior Alaska and the Alaska Range in general. And then we'll kind of go through when I sit down on the forecast desk, what's our process? What does an NWS meteorologist think about when they're producing their forecast? Just kind of go through our thought process um, to kind of help you understand how our forecast is produced and how you can make the most of it. And then we'll take questions at the end. So we want to make this as interactive as possible. So if you have a question as we're going through this presentation, just put it in the chat box, and then Mark and Philip are going to be monitoring the chat, and they'll interrupt us as we're going. And then at the end, there will be an opportunity to unmute yourself and ask questions, anything else that you may have to ask about weather and weather in the Alaska Range. So here at the National Weather Service in Fairbanks, our mission, bare bones mission, is to provide weather, water, and climate data, forecasts, and warnings for the protection of life and property. And the map there on the left shows our area of responsibility, which is pretty much everything north of the Alaska Range up to a few hundred miles offshore of the Arctic coast. And so with a very large area, we can have multiple weather systems impacting different parts of northern Alaska at the same time. We might be hopefully looking at a heavy snow event in the eastern Alaska Range, but at the same time, we might be on the phone with a tugboat captain in Kotzebue Sound, providing a marine forecast. So we'll get into a little bit more of that here in a sec in terms of program areas. And we are a 24/7, 365 operation. So you can always call us or email us any time of day. You'll always get an answer, and we will be able to discuss weather with you for whatever your need might be. And so more on our program areas. Obviously, mountain forecasting, avalanche, and snow is a big part of what we do, but we also do river flooding, anything from ice jams to heavy rainfall. We do spot forecasts for fire weather managers throughout Alaska, as well as potential search and rescue support. And then we also issue aviation forecasts every 6 hours for 12 different terminals throughout northern Alaska. So a wide variety of different weather programs that we do here at the Weather Service. So enough about that. This is an avalanche talk, and most of you are probably aware of the four big factors influencing avalanches: the snowpack, the terrain, the weather, and the human. And today we're going to be focusing on the weather. So I'm going to pass it off to Ed right now, and he's going to kind of intro a few of the forecast challenges that we have throughout northern Alaska.
Okay, thanks, Jonathan. And yeah, so we're going to tag team along through this back and forth, sort of to hopefully keep it interesting. Go ahead to the next slide, Jonathan. So forecast challenges. So on one of the previous slides, Jonathan showed the map of how large our area is, covering pretty much the northern 2/3 of Alaska. So we always like to show this image. This is our area of responsibility overlaid over the lower 48. And so all those little like puzzle pieces on the map, those are forecast offices, areas of responsibility in the lower 48. So our area here in Fairbanks, we oversee an area that encompasses at least 20 offices in the lower 48. And we have the same amount of staffing. So this makes it pretty challenging to maintain situational awareness across our forecast area. As Jonathan mentioned, we may have a big storm impacting the West Coast with rain and flooding. Meanwhile, up on the Arctic coast, there's blizzard conditions, and then an ice jam on the Yukon River. And then at the same time, there's a fire burning early season down near Delta Junction, all at the same time. So one forecaster is kind of taking care of all those things at the same time. So it does cause lots of challenges, but it does keep the job very exciting, I would say. You can go to the next slide, Jonathan. So climate. So with such a large area, we do cover several different climate divisions in Alaska. Tonight, since we're talking about the Eastern Alaska Range, I'm just going to focus on what's called the Southeast Interior division. So that's primarily a continental climate, so meaning warm summers and cold winters. And due to the Chugach Mountains down there along the coast, there is very little to no marine influence in the Southeast Interior climate region. So basically, we're blocked by that marine influence off the Gulf of Alaska. Precipitation tends to be a max in the summer with rain events, although we can get heavy snow events and a lot of precipitation. But in general, summer precip tends to be heavier than the winter precip. As for temperatures, the summer temperatures and the winter temperatures are roughly similar to central and northeast interior, maybe a bit milder though. You can go to the next slide, Jonathan. So as most everyone on this Zoom call, I believe, knows, there's a lot of variety of terrain in Alaska. So that causes extreme variations in temperature, precipitation, and winds across our forecast area. So I don't know how many of you are here in Fairbanks, but if you are, you're very familiar with temperature inversions where we can have temperatures 20, 30, 40 below in town, but well above zero in the hills. So you can have a 40-degree temperature range, you know, just in a couple mile horizontal distance. And so forecast models have a very difficult time resolving that sort of change in temperature over such short distances. And it's the same with temperature and precipitation. And Jonathan will go into the presentation a little bit later of how we adjust for those, some of those extreme variations by adding forecaster input into our forecasts. In addition to that, we don't have a lot of weather observations across the state. So that makes it very challenging to actually know what's happening on the ground. You know, is it raining? Is it snowing? What's the wind doing? So we do have to rely heavily on remote sensing, such as satellite imagery and Doppler radar where we have it. You can go to the next slide. So I like to show this map. So on the left here, this is a precipitation map. So this shows the annual precipitation across the state of Alaska. And you can see it really looks like the map I just had on the previous slide. It looks like a terrain map. So the reason for that is the green areas and the yellow areas and the blue areas are typically the higher terrain around the state. And the reason the higher terrain gets the heavier precip is that that's where air masses are lifted up and clouds form, condense, and precipitate. So we tend to have higher precipitation in the higher terrain regions. Kind of narrowing in on the Eastern Alaska range there, I've got that little inset map. What I wanted to just point out is look at between like Delta and then go south of there into the mountains. You can see that very sharp gradient in color. So around Delta Junction, average annual precipitation is roughly around 10 inches. But as you just get south into the mountains, precipitation annually is up to 20, 30 inches or more in the higher terrain. And you can see through the pass there, Jonathan, he's trying to put his pointer there, like where the Richardson Highway goes through, it's even, there's a low spot in precipitation there, and that's due to Chinook winds, which I'll talk more in depth in the next couple slides. So anyway, between Delta and the Alaska range, you can have almost 3 or 4 times as much precipitation in that short distance. So just kind of showing an example of that. So this is some data from a Natural Resource Conservation Service snow measuring site, which is called a SNOWTEL. And the one on the left is at Fielding Lake, down near Isabel Pass. And the one on the right is at Granite Creek, which is in the Delta Junction area. What I wanted to show is just the distribution of precipitation from north to south across the area. So last winter, I have that highlighted. The 2020 line was actually for the SNOWTEL at Fielding Lake, which has actually only been there since, I believe, 2014. For that period of record, that was the last spring reported the most snow water equivalent at that site. So snow water equivalent is the amount of water available in the snowpack if you melted it down. So last year there was about 18 inches max in the spring at Fielding Lake. If you go to Granite Creek near Delta Junction, there was about 8 inches of water, which was also, if you notice, I've got the red line highlighted. That was from last year, or orange line from 2020. So actually last year at Granite Creek was near the max SWE in the Delta Junction area too. But my point here is across the mountains, you can have a wide range of precipitation in the same year. The other thing I want to point out is if you look at the graph on the left, Fielding Lake, look at the minimum SWE was 5 inches one year. So just in that like 6-year span that automated station has been there, one year there was only 5 inches of water on the ground in the snowpack, and another year there was 18 inches. So in addition to a dramatic gradient of precipitation across an area, you can also have dramatic changes and variations just within year to year. And so that Fielding Lake site, so prior to the automated gauge, the SNOTEL being installed, there has been data taken manually around the first of the month in the spring, all the way back to about 1960. So that's roughly 60 years of data. And this graph is showing the maximum SWE each year. And so you can see last year was actually the highest snow water equivalent reported at at Fielding Lake. So if you thought it was a snowy winter down there in the eastern Alaska Range, well, it was. And this is our cabin there. Fortunately, we did not have our roof collapse there around Miller Creek with all that snow on it. So I guess we built the cabin pretty good. Anyway, I just wanted to show that wide variation in SWE throughout each year. And then Mark mentioned about the new Look Erie SNOTEL site that was put in at elevation above the Cantwell Glacier. It was really cool. It got put in last fall or a year ago. And if you look on the left side of the graph, by mid-October, that site had already reported over 60 inches of snow on the ground. And that peaked out in the middle of in the springtime near 160 inches. And I believe the snow sensor got overtopped with the snowpack. And then now if you look this fall here, we look today, October 22nd, there's about 23 inches of snow on the ground at the Look Erie site. So we're way behind what we were last year for snowpack in the eastern Alaska Range. Okay, Jonathan's going to take it away and talk about some online weather observations.
Okay, thank you, Ed. Yeah, so I'll go through a few of the different, now that we've kind of talked about some of the different snow measuring sites in the eastern Alaska Range, I'll go through some of the different sites and where to access the data. So there's quite a few different public government agencies that are interested in collecting weather data. Obviously, we here at the National Weather Service have a number of stations that we maintain throughout northern Alaska. The Bureau of Land Management also owns and maintains a number of remote automated weather stations, or RAWs, that are mainly used for fire weather. The FAA maintains quite a few airport weather stations. The DOT also has some road weather information stations that transmit weather data, as well as have webcams on them, which we'll show in a bit, that can be great resources. And so just kind of discussing a few different examples of different types of snow gauges that we've talked about. Down here, the Miller Creek NWS eye gauge. These are super simple snow gauges that we produce here in-house, and these measure strictly snow depth. And these get broadcast onto different websites, which we'll go through in a bit. But in the summertime, they're also used to measure river levels. So super simple snow gauge, but super effective as well, and very easy to deploy. Here in the middle, we have an example of a co-op station, or a cooperative observing station. This is the one just out back here at UAF, but we, at the Weather Service, we have a network of individuals who measure snow and send in weather information, temperature, precip, on a daily basis. And so every 24 hours, they'll go out and they'll measure snow on a snowboard and the total snow depth using a snow stake, and also sometimes the SWE from the precipitation can that's up there on the post that you can see in that picture. We'll show you where this data is available. It's not station data; it's actually a human measuring it. So there's a pretty limited number of websites that actually have that data on it. And then most of you are probably familiar with the Look Erie Snowtel there on the right. So just another type of snow measuring instrument. And so one of the first data sources that I kind of want to go through, and some of you may be familiar with this, this might be new to some of you, but it's MesoWest. And while not, well, no, none of these sources are completely comprehensive and contain all the data, MesoWest is pretty darn good, and it has uh, pretty close to everything that you could want in terms of weather sources in it. You pull up the page, you'll get a map like you have on the left here, which shows all the different stations. You can change the type of station that you want to look at. You can change the area. This is a national website, so it's not limited to just Alaska or Eastern Alaska range. You can go anywhere with MesoWest. And then in the drop-down menu here, I'll turn the pointer on to show you guys. In this drop-down menu up here, you can actually get to the current weather summary, which if you know the area that you're looking for, so for example, the Eastern Alaska range, you can pull up tabular data for all the weather stations in that area. And what I really like about this site is you can sort it by elevation, and you can also it displays the 24-hour trends in max temp, min temp, peak wind, and precipitation really well. And so that can be a really useful way to get into MesoWest and look at weather data without just looking at the homepage map. So I would encourage you all to kind of take advantage of that when planning trips, especially in the Eastern Alaska range. Another source that we like that's here produced by the Weather Service is the Alaska Pacific River Forecast Center's snow data webpage. And the links are down here on the right. We'll also be sending out a PDF document here probably about sometime in the next 24 hours to those who attended the meeting. It has all these links on them. So feel free to visit them now, or you can wait for that. Uh, but this page, what's unique about this is not only does it have all the automated snowfall observations, so from snowtells or from eye gauges, but it also has our co-op data, so where the human measures snowfall. And so, for example, I'll circle like this 14 inches down here at Dry Creek. This is actually today's observations, and so these were sent in by humans who measured the snow, not by stations, as well as out here 9 inches at Clear Sky and at Denali Park headquarters. So this is a great site. You can also use over here the 1-day change, so you can see how much snow has fallen in the past 24 hours, as well as 3-day and 7-day change, which could be useful for backcountry trip planning and doing your own avalanche forecasting.
Jonathan, do you find the computer data versus the human data one better than the other? Or is it
The computer data, yeah, that's a good question. The computer data is going to have some blips in it, so it'll often go up and down a little bit, which is a disadvantage to it. But the advantage to the computer data is it transmits much more frequently than the human data. So the snowtells, I believe, transmit once every hour, whereas most of the human measured is once every 24 hours. And so the human data is going to be more accurate, but the latency is sometimes you're better off using snowtells to get hourly trends and hourly accumulations. Does that answer that question?
Sure does.
Okay, great.
We have one more question. If can anyone submit data, or do you have to maybe register your personal site, or how does that work?
Yes. So in terms of submitting data, there's a few different options for transmitting data to the Weather Service. There is the Cooperative Observer Program, which you do have to register for, and somebody from our office will kind of go out and get you set up with co-op station, kind of like the picture that I showed in the previous slide. You also probably may be familiar with our social media posts, where we will post snowfall data from the recent storm. And anybody can submit those observations. If you take a picture with a ruler in the snow and just kind of tell us when and where you took the observation and how long that snow had been accumulating for, that'll go on our social media. And so that's also a good resource that I'll talk about a little bit later for getting recent snow accumulation. Is there any other questions about that stuff?
Nope, not yet. You're good to go.
Great. So I'll move on to the next kind of example of some of the other data viewers that are available for looking at weather observations. The one on the left here is actually the Alaska Ocean Observing System portal, and this has a variety of weather information. It's got RWIS stations from the DOT, and also has the Look Erie snowtel in it. Which one of the complaints we've gotten is that the Look Erie snowtel is not in Mesowest. However, that is going to be changing this winter. So soon the Look Erie will be in Mesowest and all the other, including this data viewer here on the right, our Weather Service weather and hazards map. It'll also be in this viewer sometime this winter. And so I would encourage you to play around in here. There's a lot of different layers you can toggle on and off and look at all the weather stations throughout Alaska. On the right here, this weather and hazards data viewer, you can also overlay the NWS forecast, so the gridded forecast. Sometimes it takes a little while to load, but that can be a good resource for looking at observations and comparing it with the forecast. So moving on, another great resource that we use a lot here in the office is webcams. And Alaska has an excellent network of webcams. The FAA has a great page here, this AvCams page. They have webcams at Black Rapids as well as at Isabel Pass in the Eastern Alaska Range. I think they all have 4 different directions that they look. So that's great for kind of determining what it's looking like outside down there, if low clouds or if it's clear and sunny like it was this morning when I grabbed these images. And then the DOT also has a great website, just Alaska 511. They have a cam down at Trims that I think has 8 different angles or something like that. So you can really use webcams to figure out what's going on in real time down in the range. And then there's a variety of websites that are produced by the private sector that you may be familiar with. I know a lot of people like to use Windy. That's here on the right. It's a beautiful interface. Presents model data, a lot of different outputs from those models. We'll kind of talk a little bit more about that and what it can be really useful for in a little while, as well as some cautions to take with it. And then Weather Underground also will actually has more weather stations that aren't in Mesowest that are privately owned stations that just don't have an identifier that you could find and access on their website that you won't find other places. So sometimes that's worth checking out. One other thing with Weather Underground is that their forecasts are not. It's not all the terrain is not resolved by the models, and so you're basically going to click on a city and get a city forecast rather than a point and click forecast for an area in the Eastern Alaska Range. But Weather Underground can be very useful for checking out weather stations that are not part of Mesowest. So now I'm going to pass it back to Ed, assuming there are no other questions. He's going to talk a little bit about the winter 2020-2021 outlook for Alaska.
Okay. Yeah. Okay, go ahead to the next slide, Jonathan. Okay, so the outlook from NOAA this year is that we are in a La Nina. So what is La Nina? Just very basic. La Nina is when we have colder than normal ocean temperatures along the equator in the Pacific Ocean versus El Nino is when we have warmer than normal temperatures along the equator in the Pacific Ocean temperatures. So what does that mean for Alaska? That's what we want to know. So this is a typical pattern for a La Nina winter in Alaska. You can see a main jet stream moving across the Pacific and into the Pacific Northwest. So that's really wet conditions for Oregon and Washington. But then there's this small little branch jet stream shooting off into the Bering Sea. And what that would do is bring some active weather systems to the west coast of Alaska. Meanwhile, high pressure is more dominant over the Gulf, like out over the North Pacific and extending into the Gulf of Alaska. So what does that mean for our winter coming up? If you go to the next slide. So this is the winter outlook that came out last week from the Climate Prediction Center. And note, this is the outlook from November to January. So this first map I've got here is the chances and probability of precipitation. So in the western and northwestern part of the state, you can see there is a chance, the models are indicating a higher chance, 30 to 50% of wetter than normal conditions from the November to January period, which would go in line with the La Nina slide I just showed you, with an active weather pattern and a polar jet stream kind of shooting up into the Bering and bringing more weather systems there and more precipitation. Meanwhile, if you go down to the south, central Alaska and the Gulf of Alaska coast, you can see the models are indicating there's a likelihood of slightly drier than normal conditions over that 3-month period. And in between, here in where the eastern Alaska range lies in Fairbanks, there was no significant signature in the long-term model runs for either wetter or drier. So we're kind of right in the middle. So if you go to the next slide, Jonathan. Now looking at temperature, on the west coast of Alaska and the Northwest Arctic, you can see there's a good chance for warmer than normal temperatures through the November to January period. And this is still in line with that graphic that I showed you of La Nina, with active weather moving up along the west coast, bringing warm air off the Pacific and the Bering Sea to western Alaska and Northwest Arctic. And then if you look down towards the southeast interior, Copper River Valley, and into southeast Alaska, you can see there's a better chance for cooler than normal temperatures over the 3-month period. And for both the precipitation and temperature, these trends continue into February and March as well, with the warmer and wetter in the west and northwest, and the possibility of drier and cooler in the southeast part of the state. That being said, that doesn't mean if we're over here in the eastern Alaska range under that little light blue area, that it's going to be colder than normal all winter. As we've seen in previous La Nina winters, if you go to the next slide, Jonathan, La Nina winters tend to have extreme swings in temperature. So here's a graph from a La Nina winter we had back in 2008 and 2009. First thing I want you to look at is look at the colors, the red colors and the blue colors. So this is for the entire winter from November through March. The red indicates temperatures in Fairbanks above normal for that day. The blue are days with below normal temperatures. So you can kind of see there are more blues than there are reds. So on average, there were more days below normal. So a cooler than normal winter back during that La Nina. But the one thing I do want to point out is if any of you guys were here in late December and early January in 2009, you may remember this deep cold snap we were in. Temperatures were running 20 to 30, almost 40 degrees below normal. And for December and January, that equates to about temperatures in the 40s and 50s degrees below zero here in the Fairbanks area in the interior. That was followed by a dramatic swing to temperatures more than 40 degrees above normal. So what that equated to, we had temperatures jump up from the minus 40s and 50s up to the 50s above here at Fairbanks at the airport. In less than 7 days, we had that over 100 degree temperature swing. And in fact, that January in 2009, Fairbanks Airport recorded its warmest temperature ever in any January in the history of Fairbanks, which was 52 degrees. So the point is, even though we have a La Nina in the eastern half of the state, eastern Alaska range, it's looking slightly drier than normal, cooler than normal. Overall for the period, that doesn't mean we may have bursts of significant precipitation or spikes in temperature up above normal. Okay, you can go to
we just want one quick question here, Ed.
Yeah.
We've got with 33% chance of a forecast, how close is that to being an equal chance of warmer, normal, or colder? With 3 categories, there would be a 33% chance of any category. Is that?
Yeah, can you go back to that slide? So if you look in the northwest part of the state, the lightest yellow orange there is 30 to 40%, and then 40 to 50, and then 50 to 60. So the farther you get towards the coast, the higher the chance of having temperatures above normal. The same with down in the southeast part of the state. As you get away from the eastern Alaska range and head down towards the Copper River Valley and maybe towards the northeast Gulf of Alaska coast, you have a higher probability of having cooler than normal temperatures over that 3-month period.
Thank you.
Hopefully that answers the question. Are there any other questions, Mark, on that stuff?
Nope, not yet. Feel free, people, to chime in here. It's helpful. If you're thinking it, somebody else is probably thinking it as well.
Yeah, and we'll try to address as many questions as we can at the end too. Okay, so I'm gonna now talk about typical weather patterns that impact the interior and most specifically the eastern Alaska range. So I kind of have gathered a handful of weather patterns, and I'll try to describe the pattern and what types of weather that brings to that region. Okay, you can go to the next slide, Jonathan. Okay, southerly flow, Chinook. So I'm sure most people here in the Tanana Valley, Fairbanks, and along the Alaska range are familiar with the term Chinook. And so what a Chinook is, it's very strong southerly winds across the mountains in our case. And so the way we get a Chinook set up is when we get a strong low pressure system move into the Bristol Bay area, you can see the low here with the big L, and the flow around the low, we get perpendicular winds from south to north across the Alaska range. And then we have high pressure, usually over the Pacific Northwest and kind of extending up into the Yukon Territory. So what this pattern gives is strong Chinook winds. So in this pattern, we also have very strong winds aloft, way up at jet stream level, all the way down to the surface. And so even on the peaks in the mountains, we'll have winds screaming out of the south. And also down at the valley level, we'll have winds screaming out of the south in this sort of scenario. So wind gusts 60 to 80 miles per hour are not uncommon, especially when along the Richardson Highway, like north of Black Rapids and south of Delta Junction. This also leads to very dry conditions on the north side of the Alaska range because we're getting the precipitation is being blocked by the Alaska range, and most of the moisture is being squeezed out on the south side.
Ed, just a quick interruption.
Sure.
With one of these bigger snowfall or Chinook events in the eastern Alaska range, is there a model that is typically performing better?
That's a good question. So, it depends on the, it often depends on the event. And Jonathan's going to talk a little more about model choice. And, we've got a handful of models and how we decide which model we prefer for that specific time frame. Or maybe sometimes the models all show the same story and we can go with a blend of all the models. But it would definitely be event specific. Okay, you can go to the next slide, Jonathan. So I kind of wanted to break down the Chinook wind because it's a really interesting phenomena, and especially if you're into thermodynamics. So in the middle here, I've got a little schematic image, and this is, imagine a cross section from south to north, going from Paxton to Delta, basically kind of along the Richardson Highway there. So on the south side, or on this graphic on the left side, would be the windward side in this case. And so this is a side where you've got the winds coming out of the south, air is being forced upslope over the mountains. And so as this air is rising, it's cooling, it's condensing into clouds, and then eventually precipitation. And so what happens when you condense moisture from the atmosphere is it releases latent heat into the atmosphere. So it adds heat to the air parcel, as well as squeezes all the moisture out of it. So then as that air mass rides over the top of the mountains and starts to descend on the other side, or the leeward side, or we also call the rain shadow side, that air starts to descend and it compresses as it's descending, and it starts to warm adiabatically. And so what that does is you actually end up with much warmer air mass on the north side of the mountains than you do on the south side where it started. And that's primarily because of that latent heat added from the condensation, and then also the compression of the air descending. And so just in this diagram, you can see it says in Paxton the temperature was 10 Celsius. But on the delta side, that same air mass is now 18 degrees Celsius, so significant warming. So I know most of you, if you've gone down the Richardson Highway, you get down to delta, and the winds are screaming out of the south, and it is not uncommon for temperatures to be 40 to 50 degrees Fahrenheit, in the middle of the winter. And notice here on the bottom, a Chinook is actually a Native American, Native Indian word for a snow eater. And so that's because a Chinook is a warm, dry wind that sublimates the snow. You can go to the next slide. So I put together a couple little schematics here. So the one on the left is winds and temperatures. So starting down at Summit Lake, this would kind of be the type of weather you would encounter during a Chinook. So generally down at Summit Lake, there may be just light winds out, or maybe not light, maybe, I don't know, 20 miles an hour out of the southwest or whatever. But as you get further north into the gap in the mountains, the winds start to increase. So you'll see I've got gusts 20 to 30, temperatures maybe like 25 to 35. But then as you get further north towards Black Rapids especially, I'm sure most of you have noticed snow and dust blowing on the Delta River just to the east, west of the highway. And that's where you really start to get that descending air and the acceleration of the winds, and also warming temperatures. And then as you get towards Donnelly Dome is where we usually have the maximum winds near Donnelly Dome and then along the Delta River there, where gusts 60 to 80 miles per hour are very common during a Chinook, and temperatures well above freezing in the middle of the winter. The other thing I want to point out in a Chinook, these winds also, I'm only highlighting what's happening along the Richardson Highway, but you'll also have similar strong winds coming out of the other gaps through the mountains and passes, such as along the Gerstle River. If you go further to the west, coming out of the Wood River, and then obviously over by Healy, coming out of the mountains along the Parks Highway. And looking at, yeah.
Sorry, could you review latent heat release and how does it relate to precipitation?
Oh, okay, yeah. So say we have an air mass, and it starts rising. I mean, as it rises, it cools and then it condenses into a cloud. And when you get that condensation happen, heat is released during that thermodynamic process. And so it actually warms up that parcel of air. And that air is now holding more heat than it would have if it hadn't condensed, if the moisture hadn't condensed out of it. And so, like I mentioned, that warmer air mass is now going to go over the mountains and descend down towards Delta. So you end up with much warmer conditions on the north side of the mountains, or on the lee side. This same phenomenon happens in the Rockies, where the jet stream flows from west east in most cases, perpendicular to the mountains. Okay, so now looking at this graphic on the right, oops, can you go back, Jonathan? This is the precipitation. So I showed the winds and the temperatures. So during this Chinook flow, you can have really heavy snow on the south side of the mountains because you've got the air mass all the moisture being squeezed out of the air mass. I'm really focused on winter here. If it was summer, this would be rain, not snow. So generally you can have heavy snow south of the divide. And then as you get further north, the snow drops off dramatically on the north side of the divide due to that rain shadow effect. But you can see here, we do get, due to the gap along the Richardson Highway, some of that snow does spill over as far north as almost Trim's Camp. So the Fielding Lake site often has very similar amount of snow that I have at our cabin, which is down near the Cantwell Glacier towards the Trim side. But as you go north of there, you'll notice, I'm sure when you've driven south out of Delta, you may leave Delta and you're like, holy crap, there's no snow. So what happens is you're getting into the Chinook zone where you've got these strong winds that are sublimating any snow that may be there or preventing any snow from falling because the air mass is so dry. And then you get further south and you get to Trims, and all of a sudden the snowpack is getting deeper and deeper and deeper very quickly. So that's sort of what's happening in that situation.
Hey, Ed, so apparently wind is getting people pretty excited. So if Jonathan or Ed, if you're quiet and you can check the chat too, feel free. Couple quick questions about winds. Are the high winds on the north side a result of channeling through the pass, or is there another mechanism causing this?
Yeah. Okay. So in a Chinook, the Chinook, we have strong winds. Let's just say at all levels in the atmosphere. So we've got strong winds aloft, sort of at jet stream level too. And so in a Chinook case, when you've got these really strong southerly winds, with the jet stream basically shooting straight at the northward at the Alaska range, you'll get wind blowing over the summit peaks and over the ridges and divides. It's just enhanced through the valley locations, like through the gaps. And so you get really strong winds down at the surface level. You may have noticed during a Chinook event, you get the lenticular clouds too, or the mountain wave clouds off the mountains, off the peaks that, sometimes extend almost as far north as Fairbanks during during a strong Chinook. So actually the next sort of wind event I'll show you is another southerly wind event or wind scenario, but generally does not have strong winds like on the higher terrain outside of the valleys.
And then one person is asking that they feel like over the last 30 years that it's gotten windier in the recent years in the Alaska range. Passes over. Have you identified that as a trend?
I haven't. Yeah, I haven't looked at the data. It's easy to. I mean, even myself, it's either like, oh yeah, it seems like it's been really windy, like even here in Fairbanks over the last 10 years. But until actually looking at the data, I guess I can't answer that at this point.
Okay, and then I think the last question is more avalanche based, but how do we know the wind load from a Chinook type of wind?
Yeah, and so I would assume like the wind load, most of the snow is going to be blown off the ridges, blowing to the north, so loading on the northerly facing slopes during a Chinook event. Granted, terrain is going to, winds are going to funnel down valleys too, so it may not be from a due south wind. You may have winds that turn and are variable directions, but generally with a southerly component. Okay, we'll go to the next slide. Okay, so still talking about winds. So we have another scenario which is called a gap wind, and so this is where we don't have that jet stream aimed right at the Alaska range. This is actually where we have, it could be a weak low pressure area just kind of sitting on in the Tanana Valley with high pressure down over, say, the Copper River Valley or somewhere over south central Alaska. And what that does is it creates a pressure gradient across the Alaska range. And so wind will blow from high to low pressure. And so what we do is we get wind channeling through the mountains, and the strongest winds in this case are just going to be through the gaps, and primarily through the gaps that transect the entire mountain range. So, for instance, the Parks Highway and also the Richardson Highway, where you've got that gap from the south to the north. And often the winds are not nearly as strong as a Chinook, maybe in the, I don't know, 30, 40, 50 mile an hour range. The winds are much shallower, so the ridge tops and higher elevations in the Alaska range may not necessarily have strong winds like the valleys do, where the wind is being funneled through the valleys. Okay, and another wind. This is the Tanana Valley Jet. So this is, you may have, I think the Weather Service, we're the ones that I think we coined this term years and years ago. And you're probably thinking this isn't a jet that, that you'd go fly in. This is what we call it, like a local jet stream that's at the surface. And so this is a katabatic or a down valley wind that develops in the Tanana Valley. So the scenario that we typically get this is when we have high pressure over the Yukon Territory or near the Alcan border and a dome of cold air. And we get some sort of low pressure system move up into the Bering Sea, which is not uncommon in the winter. And basically that's setting up a east to west pressure gradient across the Tanana Valley. And so once that sets up, we start getting wind blowing down the Tanana Valley, typically from Dot Lake to Delta, and oftentimes as far west as the Parks Highway. And this often results in cold temperatures, where the Chinook is very warm temperatures. This is when you're in Delta and it's screaming windy and really cold. If you go to the next slide, Jonathan. So here's kind of the close-up of this scenario. So I drew in the cold air in the upper Tanana Valley. So once we get the pressure gradient across the Tanana Valley and we get the wind starting to blow, that cold air starts getting sucked down valley. And then actually down valley is downhill. So imagine that as cold water up there that starts pouring down the Tanana Valley. So that cold air mass starts blowing down the Tanana Valley, and you can see it starts around Dot Lake, often peaks in the Delta Junction area. And then as it gets into the flat south of Fairbanks, it often fans out a little bit. It's not as constricted. But in strong Tanana Valley Jet cases, you can have it all the way over in Nenana and the Anderson area. Fairbanks is never impacted by these. So here in Fairbanks, it may be clear and cold and 20, 30, even 40 below, but just south of the Tanana River, you've got winds screaming out of the southeast and maybe temperatures near zero. So it can be 40 degrees warmer just to the south, but your wind chill is then 40 below. So, but we can get gusts, 30, 50 miles per hour in Delta Junction with this case, in this scenario. But you may arrive in Delta and you're like, holy crap, it's going to be cold in the mountains. But the minute you drive just south of Fort Greely, you're kind of getting out of the Tanana Valley, and then you get into calm winds, and the winds in the Alaska range may be relatively light. Okay, you can go to the next slide. More wind. Okay, so I hadn't talked about north winds. So the setup for north winds is when we get cold northerly flow or an Arctic high set up over the interior. So this is the case we're in the interior where we may get strong temperature inversions, very cold in the valleys. There may be some channeled areas with wind blowing, but as you get down towards the Alaska range, we get that cold air and also a pressure gradient. As I mentioned, winds tend to blow from high to low pressure. And so you get north winds blowing from the north side down to the south side. And you can typically get gusts 30 to 50 miles per hour, cold wind chills, and and often, especially when you get south of Trims or Rainbow Ridge, areas of blowing snow that may close the road or reduce visibility considerably. And down there by Isabel Pass and Fielding Lake, they've got the DOT has the markers over the road so they can see where the road is during these really windy conditions. You can go to the next slide. Is there a question too? No? Okay.
Sorry, there is a quick one. Will the different type of wind cause different type of snowpack? Do we read the forecast? How do we read the forecast knowing the type of wind?
Yeah, so in our forecast, our forecast would say north winds, and temperatures would generally be colder. So I guess I'm not sure exactly if that answers the question or not.
I think we're asking for the specific snow style, which I'm not sure is your.
Yeah, that's not really my expertise. I don't know if you can speak to that, Mark. I mean, generally in this pattern, it's cold air mass, so it's going to be cold temperatures with very dry snow blowing around, versus the south winds where the snow moisture is much higher and warmer.
Yeah, unfortunately, I can't accurately answer that either. That's where we're in an ideal world, we would have an avalanche forecaster who's out there digging in the snow every day to provide that avalanche forecast, and that's on our future plans, but years out.
Okay.
And with these patterns that Ed has discussed so far, these are all pretty dry patterns, so you wouldn't be accumulating any new snow with these. He'll kind of talk a little bit more about patterns that would produce snowfall in a sec, but these are all dry patterns.
Yeah, except minus like the Chinook pattern where you get a lot of snow at Fielding and up at Gulkana and Summit Lake and places like that.
Right, on the south side.
On the south side, yeah. So same sort of little map here. This is just kind of opposite of the one I showed with the Chinook winds. The north winds are not as strong as the Chinook wind, but you get these gusts, the strongest winds. It may be calm in Delta even in this case, but then you get further south, and then as you get south of Trims, that's where the winds really start to pick up. And then if you're down by like Fielding Lake and down towards Summit Lake, you can get really strong winds blowing out of the south. Okay, you can go to the next slide, Jonathan. Okay, so this is southwest flow. So this is the flow that I love to see, but I never bet my hat on it because we can get totally burned. The reason I like seeing it is this is the type of pattern that brings, in the winter, heavy snow to Fairbanks. But you can see, so in this sort of pattern, we get a low that moves up it comes up the Bering Sea and heads towards like the Bering Strait there, where I've got the L, with high pressure kind of anchored down over the Gulf of Alaska. So what this does is it puts us in this southwest flow pattern where we get a good stream of moisture off the Bering Sea and North Pacific. So in this case, the moisture and the winds aloft are sort of in line, if you can use your pointer there, Jonathan, with the Alaska range. And so there's not any terrain really to block the moisture with this sort of pattern. The one thing that can go wrong with this is if the winds turn a little bit too southerly aloft, that can actually turn off the precip here in Fairbanks, because then we start to get a little bit of blocking of the precipitation by the Alaska range. So I never put my hat on this until like we're looking down the barrel of the gun and the system's right on us. But that being said, for the eastern Alaska range, this is actually a dry pattern. So we may be here in Fairbanks and it's dumping snow. And this is the case, this sort of pattern can bring us like that freezing rain or a mix of rain and snow, just because of the warm source of moisture off of the Bering Sea. But if you go to the next slide, Jonathan, I've got a little schematic here. So you can see often this pink area I put is where you could have significant snow falling in this pattern. But where that blue arrow is, with this south or even westerly flow, the mountains are actually blocking the precipitation from getting over to the eastern Alaska range. So often you could drive out of Fairbanks, get to North Pole. It may be dumping snow in Fairbanks, but North Pole or Eielson may not even get any snow out of these scenarios. And then for Fairbanks, if this flow aloft turns a little bit more southerly, we may get blocked and all the snow is falling to the west of us near Nenana. So this type of pattern is really wet for a lot of the interior, but unfortunately not for the eastern Alaska range. Okay, you can go to the next one. Oh, okay. So yeah, so this is the type of, in this type of pattern is when we get these warm air masses that kind of slide in to the interior. And this is just a little, I won't go into too much detail here, but just sort of the process that happens of how we get snow versus sleet versus freezing rain and rain. So where we want to be in the winter is over in the far right of this graphic, is in the snow part, where we don't have any warm air here. In this case is above freezing temperatures. So imagine this yellow is like above freezing temperatures. So as we start to get warm air come up, that warm air is lighter or less dense than the cold air. So the warm air tends to ride over the cold air that may be in place at the surface. So the closer you get to the warm air and the deeper the warm air gets, the better chances you get for getting a mix of sleet, freezing rain, or even just straight rain when there's temperatures are above freezing all the way down to the ground level. Okay, you can go to the next one. Okay, so let's talk about a snow scenario for the Eastern Alaska Range. Another one. So this one brings some snow to the north side of the mountains. So this is what we call an easterly wave. And this same scenario happens in the summer too. This isn't a winter phenomenon. So what we do is we have like high pressure kind of out over the Bering Sea, but we get a low that comes up into the Gulf of Alaska, often comes over the top of Yakutat there, and then moves into the Yukon Territory or along the Alcan border, and sometimes even up, moves north into the interior and then starts to move back towards Fairbanks. So what this does is it spins moisture up out of the Gulf of Alaska into the southeast part of the interior and the Eastern Alaska Range. And this can result in significant snow in the Eastern Alaska Range. And if you go to the next slide. So yeah, so in this scenario, we can get, so the flow around the low, the surface winds and the winds aloft can actually, are coming out of the north in this scenario, and we're actually getting upslope enhanced snow on the north side of the Alaska Range. So often we'll get heavy snow here, down south of Tok, all the way over to, the Granite Mountains. And some of that snow will often get even further up towards the divide. But then in that scenario, like if you're down in Gulkana or down at Fielding Lake, the mountains now may be blocking the precipitation, the heavier precipitation from reaching you there. And then often in these cases, the snow doesn't even get as far west as Fairbanks. And I know, Jonathan, on that snow map, you showed there were 14 inches of snow at Dry Creek, which is just down by the Johnson River. And so we had a couple of these events that really built up their snowpack down there when we had these easterly waves. So they've got 14 inches of snow on the ground down there already. Okay, that's all I've got on sort of just a summary of some weather patterns. And Jonathan's going to take it over from there.
Oh, yeah. Do we have any questions in the chat so far in terms of weather patterns?
I've got one that just came in. Is it easy to tell from the forecast discussions from National Weather Service, what kind of pattern we can expect? So do you easily identify those patterns that you just discussed?
Yeah, we'll typically talk about the direction the snow is coming from, or we may sometimes people mention easterly wave. We try not to get too technical in the forecast discussions. Jonathan is going to talk about forecast discussions here coming up as well.
And then the most common snow pattern was this last one here.
For the north side or the south side?
I'm going to go north side.
So north side would be this sort of easterly wave where we get lows that move into the Gulf of Alaska and then up over Yakutat and into the Yukon Territory. That sort of spin moisture up out of the Gulf of Alaska into the eastern interior.
I think what people are waiting for is, can they get a code word in the forecast, the forecast discussion that says take the weekend off, clear your calendar.
Yeah. Okay. Well, yeah, we'll have to do some serious training to our forecast staff here to add that secret code word in there into the forecast discussions. It's that has been noted, Mark.
Okay, thanks. Just trying to make your service better for this public.
Okay, take it away, Jonathan.
Okay, so thank you so much, Ed, for kind of going through quite a few examples of different weather patterns that can produce wind and snow for the Alaska range. And so from here, I'm going to kind of go through the forecast process. So what are we thinking about when we're on the forecast desk, specifically looking at days 1 through 3, the short-term forecast? So what kind of data are we looking at? How are we understanding the patterns, and how are we trying to portray that in the forecast? And by kind of going through this, my hope is that this will help you guys understand kind of where the forecast discussion comes from, different terms that we may put into the forecast discussion that can kind of give you those keywords of here's what we're looking at, and maybe it's going to be a big snow weekend. So moving to the next slide. So this is a picture from our office. And so it's a lot of monitors. We've got 5 up at each workstation. Everybody does this a little bit differently, but this is kind of a general setup where we've got satellite data up on a big monitor above all the rest of the monitors. And satellite data is huge for situational awareness for us, just due to mainly the lack of radar coverage in Alaska. Really, we only have in northern Alaska radars at Fairbanks and Nome that extend a couple hundred miles in either direction that we get returns from. And so satellite is really crucial to helping us understand what's going on currently. And then we'll often have a screen with model data, or sometimes 2 screens with model data that variety of different levels. We'll get into that a little bit more later. And then we have a screen here in the middle, GFE, which is our graphical forecast editor. We'll take some zoomed in shots of that to kind of show you how we go about editing the forecast in there. And then 2 screens here on the left or on the right side here. One usually has observations, can be satellite, could be something like MesoWest. My display is typically MesoWest. And then one for aviation, since we do issue these aviation forecasts every 6 hours and monitor them constantly. So that's always part of our setup as well. And so I want to start off by kind of explaining this process that we call the forecast funnel. And there's really 2 different ways that you can think of the forecast funnel. There's how it's portrayed here with understanding things on what's going on in the hemispheric scale. So really kind of what's going on in the North Pacific is kind of the first step to diving into the forecast. And then what's going on the synoptic scale, which is the 500-mile scale. So what's going on in the throughout Alaska, really, where are the big long waves, where are the short waves, where are the highs and lows, and main surface features that we're looking at when producing the forecast. And then on the mesoscale, so the smaller scale, that example of a mesoscale feature would be a Chinook wind through kind of the Delta Greely area. And then the time pyramid on the right, how much time are we spending on each of these segments? This is kind of our general guidelines for how we approach the forecast. And as I go through the next few slides, the other thing that I want to think that I think is valuable to think about is this cone. And if you think about forecasting, it's kind of like putting different pieces of information into the cone. So you're like you're dropping different model data, different observations into the top of the funnel, and ultimately producing something at the bottom, which is the forecast. And so I'll talk a little bit about the inputs to that cone here in a sec. And so when we come in on the short-term desk, our first goal is to really understand what's happening right now. And we do that through observations, satellite, and radar. And so here on the left, Mesowest, kind of the observation source of choice for most of us. Looking at temperatures, also looking at 24-hour precip data. Where has it rained? Where has it snowed? And then correlating that to satellites. So we can see current systems on satellite, where the clouds are, what kind of snowfall that dropped. Sometimes even on our high resolution polar orbiting satellites, we can pull ups and see where the snow has fallen, see the terrain and see the snow on the terrain and those true color wavelength satellite bands. We'll put a satellite link here. We'll give you one of those in just a bit, that you can see all the different bands of satellites, or at least a lot of them that we look at here in the office online. And then using radar coverage where we have it. And so um, really over Fairbanks and over Nome. And this the Fairbanks radar unfortunately doesn't extend all the way down to the eastern Alaska range. We get coverage about as far as Delta, but really not quite good coverage all the way to Delta. So these are kind of the first few things that, as a forecaster, we put into this cone of producing the forecast. Understand what's happening right now, and then from there move on to our model data. And so moving on to that model data, it's really still maintaining this top-down approach. And so on the left here, we have this 500 millibar chart, which is kind of the baseline height. It's approximately 16 to 20,000 feet up in the atmosphere, which is really it's a good level to look at because models excel very well at predicting upper level patterns. It's above the influence of what we call the boundary layer. So the lowest level of the atmosphere that is influenced by surface characteristics like permafrost, terrain, which are really hard for models to resolve. But 500 millibars is generally an excellent level for understanding the general pattern of what's going on. And so going back to observations, what we'll typically start our day with is looking at weather balloon launches. So radiosonde observations and comparing where those balloons measured the 500 millibar pressure level with the pressure level that the model is showing. And what that allows us to do is determine which model initialized the best or which model has the best grasp on the current situation. So for example, if a model is showing 540 decameters at 500 millibars, but the radiosonde only showed 500 or we'll say the radiosonde showed 546 decameters, but another model is closer to what that 546, we know that model is probably better in line with the situation at hand. And there's definitely days when we come in and all the models will be in good agreement and they'll be the same. Maybe there'll be a couple millibars too high or too low on a few features, but we can use our knowledge of the features. So say they're a little bit too low on a high on a ridge, so high 500 millibar heights. We know that the pattern might be a little bit slower than it would be if they were a little bit too low or in line with what the models are showing. And so we can use that kind of baseline knowledge of how the model initialized to either speed up or slow down the features in the forecast or pick the faster solutions to the model rather than the slower solutions. And so we do spend a good amount of time looking at the upper levels and how they initialize. And after we've moved, kind of gotten a good understanding of the upper levels, we'll move down to the mid levels. And so this middle picture here is a map of 850 millibar temperatures. And 850 millibars in Alaska is generally 4,000 to 5,000 feet elevation, slightly lower in the wintertime usually. And what the 850 millibar temperature gives us is a great representation of just the temperature of the air mass. It's the 850 millibars is usually the lowest level that isn't influenced at all by the boundary layer. And so understanding what's going on as close to the boundary layer as possible can give us a good idea with the general pattern of what the temperature is going to be, where the temperature swings are going to be, and just kind of general weather, especially not related to precipitation. And once we've kind of taken a good look at the mid levels, another thing that we like to look at is 700 millibar relative humidity. That'll give us a good idea of how much moisture is in the atmosphere, how much possible precipitable water there is for a potential snow or rain event. Um, and those are also good, those are great mid-level features that we all look at when producing the forecast. And then moving down to the surface, and this is where this is where models get, it gets a little bit dicey. And so models struggle with resolving terrain. Most models, even high resolution models in Alaska, are 3 kilometer resolution, whereas in, while there are 3 kilometer resolution grid cells, the general rule of thumb is that a 3 kilometer model probably isn't going to resolve a terrain feature that's less than 12 kilometers by 12 kilometers. And so models have an extremely hard time resolving the Alaska range, let alone something like Denali. And that really comes into play when looking at surface features. Other things that influence surface in Alaska are things like permafrost with super cold ground. Um, and so really understanding the forecast from the top down can help us adjust for what's going on at the surface and making adjustments to the forecast as we go through it. And so after we've gotten this understanding of the pattern, what's going on currently, and things to look out for in the models, we have, this is a zoomed in graphic of our graphical forecast editor. And so this on the right here is a wind grid with, on the left is all the different models that we can choose from. So we'll typically spend anywhere from 1 to 3 hours at the beginning of any given shift going through steps 1 and 2. And if it's really busy, it might be 3 hours followed by a discussion with all the forecasters on shift to figure out which models we're leaning towards going with based off of initialization and kind of run-to-run consistency, which I'll get into a little bit more when I talk about the discussion. And so once we have those steps 1 and 2 done, and we go into here, we're blending models, the ones that we like. Maybe we're just going with one. Maybe we're all in on one solution. Maybe models have a wide variety of solutions, whereas a blend would kind of wash all those together and give us not really a solution representative of any of the models. And so that's where, as a forecaster, we get to pick and choose what we're going with. So we may throw part GFS, part European model, part North American model into a blend, or we might just go with the GFS. And so we can pick wind directions, wind speeds, and then we have a variety of tools up here on the top that help us kind of pick, I guess, the right grid cells for adjusting, for example, the Alaska Range Chinook Wind, which I think is the next slide here. Yeah, so an example of this is, for example, on the left here, straight model data. Models will generally get that we have southerly flow in the Alaska Range, but they will not pick up on the extent or the strength of that southerly flow wind. And so by looking at things like surface pressure gradient across the Alaska Range, as well as general flow aloft. So for example, a Chinook event where you're getting southerly winds screaming over the mountaintops for a long stretch, long fetch of distance, we can kind of take those things into account and bump up the winds over what model data would output for areas in the Alaska Range that are prone to these events. And so this is where we really add forecaster knowledge to the forecast in the Alaska Range and throughout other places. Really, once we've loaded this model data, it's a forecaster's job to use their local knowledge of the terrain and of the pattern to add value to the forecast in areas such as winds or temperatures where there's an inversion that models aren't going to pick up in order to produce kind of the most useful forecast. And so after we've done all this kind of forecasting and model ingest and model analysis, that really kind of takes up the first, I'd say on average, 5 to 6 hours of a shift. Where does the forecast go, and where can you access it? I guess I'll pause here. Are there any questions about forecast process? I'll go back a little bit if anything's come up.
We had one question, but Ed just answered it. Does the National Weather Service point forecasts account for your blended model choices?
Yes. Yes. The answer would be that the blended model kind of goes into the grid, and I'll discuss where the grids go, the gridded forecast, the point and click here as we move forward. And so where does the forecast go? I'll start off with our website and kind of going through how to access it, how to make the most of Weather Service resources. So weather.gov/Fairbanks, that's our website. And something else I want to kind of promote, obviously we know that this looks pretty old and it's not as user friendly as a lot of other sources. We're working on that, and digital.weather.gov is a place where you can view actually just the plain old grids, so not a point and click where it has output with text that may give you snow accumulation. This picture on the right here is just strictly the gridded forecast output that you can step through in time here on the top here. So it shows each of our 3-hour grids with any number of variables from wind speed to max temperature to snow amounts. And so when you pull up the front page of our website, you'll have an opportunity to zoom to different areas here up on the top, and watches and warnings will be highlighted. If you click on the watches and warnings, you'll get to a page, I guess it's not the next slide, but you'll get to a page that shows where you can read the statement as well as get a point and click forecast for that area. And kind of getting into some of the other forecast products here, sounds like people in this webinar are very familiar with the area forecast discussion, which I'll kind of talk about here, as well as the point and click forecast, watch warnings and advisory statements, and then social media updates are kind of the main ways that this forecast gets communicated through Weather Service channels.
Hey, Jonathan.
Yeah.
Yeah, there are a few good questions that came in.
Okay.
You want to? I can read them to you. I was going to try to type them, but I think it'd be if you just answer directly. Yeah. So, yeah, the first one is there a go-to model you like most that you find yourself using more than others, or is it largely regionally dependent? Selfishly, mostly focused on the Chugach. I don't know if you want to answer that, or I can answer that too.
Yeah, I can answer that. It does depend on the day. Some models have certain strengths that they're good at. So for example, high resolution models that are 12 kilometers or less are going to do a better job capturing winds than, for example, a 22 kilometer resolution model like the Alaska GFS, for example. So we may go with, if model solutions are all pretty similar in terms of the tracks of highs and lows throughout Alaska, we may go with, for example, the NAM, the North American model for winds, but we may go with the GFS for something else, for temperatures or snow amounts. And so it's looking at the models as a whole to understand why they're producing the solutions that they are. But it's also understanding when the models are in good agreement, when we can kind of use each model's strength to incorporate into the forecast.
Okay, there's another model question. While you're on a roll, I'll let you answer this one. I think you.
Okay.
Have you evaluated the skill of these models and blended models?
Yes. So that's actually another piece that we produce this internally, and I don't think it's a public page that anyone can get to, but another piece of kind of the step 1 and 2 here that we went into, we have a verification page that tells us we can look at the past 7 days, what the models have done, and which model has verified the best based off station data, as well as the past 30 days. We can look at that for a wide variety of parameters. So for example, minimum temperature, maximum temperature, quantitative precipitation, or probabilities of precipitation. For 3 different regions in Alaska, 3 different regions of northern Alaska. So the West Coast, the North Slope, and the Central and Eastern Interior. And so that also goes into factoring in which model we're going to lean towards in a forecast. If a model has been performing really well, according to verification, and the pattern hasn't changed a lot, we're probably more likely to include that as part of the forecast, or we are more likely to include that as part of the forecast than models that haven't been verifying very well. And so those not only are just the baseline, the NAM, GFS, ECMWF models factored into that, the blends are also analyzed. And so some of the blends even take into account our previous forecast. So what's the previous forecaster thinking in terms of what's happening, so that we're not kind of overriding and starting from scratch every single shift that we come in. I guess that's kind of how I would answer that question.
Okay, while you're on a roll, I'll give you one more.
Okay.
Are there advantages to radar versus satellite?
Yes, radar definitely has its advantages. Satellite's going to show cloud cover very well, and specifically the high clouds. Radar is going to show. It's going to generally, especially close to the radar. So if you think about a radar beam, the beam is actually at an angle, and so where the beam is scanning close to the radar, you're actually getting returns from lower in the atmosphere than you are further away from the radar. And so just being able to kind of assimilate that with the satellite data, knowing where the cloud cover is and where, so maybe the satellite is showing a lot of low clouds far away from the radar, but the radar might not be picking up on precipitation there. Just kind of using them both in tandem is really helpful when it's possible. Obviously, we don't have radar coverage in the Brooks Range, so for the Brooks Range and the North Slope, we are relying on satellite data. Okay, did that answer that question?
Yep, I think you're good to go.
Okay, so we will keep going here. So we'll kind of get into the area forecast discussion. So this is where the forecaster or the forecasters, depending on how the day's tasks are split up, we're gonna try and explain to you the pattern and what's going on. And as Ed said, we try not to get too technical, but we try to provide as good of an overview as possible for the pattern that's going on, as well as the impacts for that pattern. And so typically the forecast discussion is split up into a few, really 4 different sections plus a few other bonus sections that kind of depend on the year. And so we'll start off with analysis and model discussion. So we'll discuss how the model's initialized, which ones we're going to go with, why we're going to go with them, and then the confidence in the solutions that we have. Maybe the run-to-run consistency has been really poor. So for example, the 12Z GFS run shows something completely different on day 3 or 4 than the new 0Z model that just came out, and they're flip-flopping. So we may not have a lot of confidence in what's going to happen in days 3 and 4. Whereas in other cases, the run-to-run consistency might be really good, and we'll be able to kind of say, okay, we're going with a blend of all the models because they all show something good, and they've been consistent. And so we'll try and discuss that in the analysis and model discussion section. Oftentimes, confidence is going to be pretty low if we're in an easterly flow pattern, whether that's in the summer or in the winter. One of the big failure modes of models, as I've kind of mentioned, is resolving terrain. And when you're getting a low pressure system moving kind of from the Yukon, from the Gulf of Alaska through the Yukon all the way into the interior, the Yukon is all mountains, and so there's a lot of room for error in how the models are treating that low pressure system as it moves from the Gulf all the way into the interior. And so that's kind of when you see easterly flow, a lot of times confidence is going to be a little bit shakier in those situations, a little bit more wiggle room for possible solutions. So we'll try and portray that as well in the analysis and model discussion. In terms of the rest of the discussion, we'll go into the forecast areas. And so for the Alaska range, you'll want to look at the central and eastern interior as kind of a overarching general trend of what's going to happen over the next 3 days. for the short-term discussion. And that's going to be pretty basic. It may allude to highs and lows, but may just kind of say it's going to be sunny followed by a big snow event. And so that's a good place to look for kind of a quick discussion. And then we'll go into the extended forecast and discuss model solutions and confidence for days 4 through 7 as well. That's kind of our extended range. And then seasonally, we may also include sections for fire weather or hydrology, especially during the summer when we're getting rain rather than snow. And so key confidence phrases to look for in the forecast discussion are really these 6 or 7 that I have up here. So leaning, really, what model are we leaning towards? Is the GFS leaning toward more snow than the NAM? And why are we going to go with it for that reason? That's a good kind of phrase to pick out, which can kind of help you assess uncertainty in the forecast. A blend is kind of, as we discussed before, what models are we putting into the forecast? Is it 50% European model, 50% previous forecast, for example? And we'll kind of discuss what type of blend we're going to go with, as well as run-to-run consistency, which I discussed a little bit briefly earlier. Are the models in agreement as the new runs come in, or are they showing different, are they flip-flopping back and forth? Has one model been sold on one solution for a number of days and all the rest of the models are starting to kind of line up with that one, which is kind of a good sign that, okay, we're going to trend with the model that's had that solution for a while. Model agreement as well as phasing and timing. Some models might be faster than others. Are we going with a faster solution? Are we going with a slower solution? And what are the impacts of going with that solution, for example? And then confidence and differing solutions are also good things to pick out of the AFD. Okay, so that was kind of my overview of the forecast discussion. Are there any questions at this point in the chat?
Yeah, we've got one about protocols. It's can you get all the forecasters to follow this protocol? Many times they do not, which I think is maybe the key confidence phrases they're talking about.
Yeah, the key confidence phrases. Yeah, it is kind of every forecaster thinks about things a little bit differently, and so he or she is going to try and communicate that as best they can. But obviously, consistency across the discussion it is something that we're working on and trying to improve, especially not only just the sections of the discussion, how it's formatted, but with these key confidence phrases as well. And something else to kind of pick out of discussions, when the discussion goes to the website, there's a lot of terms that you can click on that'll take you to a glossary. So maybe we're talking about vorticity or something, and you can click on that and read the definition of that in a simple way that can maybe help you understand the discussion a little bit better.
I think so. And then I think Ed is giving credit for the picture, maybe. Is that true?
Yeah.
Yeah,
The background was.
We were together during that picture too.
Okay.
Yeah. Okay, so I'll move on here. We don't have a whole lot of slides left, so it looks like we'll probably have some time for questions at the end. But I do want to kind of go over the point and click forecast. So this is probably the easiest way to access the gridded forecast that we're going to put out. And so you can go to our homepage, zoom in anywhere, and click anywhere for a forecast. And what that's going to spit out is this detailed kind of 5 to 7 day synopsis of something that I'm sure you guys are all familiar with. But each of these grid cells is 3 kilometers by 3 kilometers, which really kind of corresponds to the highest model resolution that we have for any models that we receive here in Alaska. So for example, the high resolution rapid refresh model, or the HRR, if you guys have heard of that model, is a 3 kilometer resolution model, and that matches the resolution of our grid cells. And so if you click on one, the point forecast is going to resolve the terrain as best as we have in the grids. So it's kind of a good way to see we encourage people, if they're planning a trip in the range, to click around. So click at value level and then click at elevation. And down here in this point forecast details, it'll show you the elevation that forecast is for. And it'll also show you the last time this was updated. Generally, the grids get updated 2 to 3 times a day. Once in the afternoon, anywhere from like 1 to 4 p.m. Once in the evening, sometime between 6 and 10 p.m. And then once in the morning, usually between 3 and 6 a.m. are the typical update times. And so that's something that you can also look at as you're going through the point and click. And so also on the point and click, you'll get an opportunity to read watch warning advisories and special weather statements. If they're in effect, they'll show up here on the graphical forecast at the top, as well as under this hazardous weather conditions tab right here. So that's kind of how we recommend using the point and click forecast. I also want to briefly touch on social media. If you guys follow us on Facebook and Twitter, we often post these storm total snow maps that you won't find on our website. These are produced out of Graphical Forecast Editor from our grids that kind of do the best job that we can at portraying some of the uncertainty in the forecast. So it'll give you a range of expected snow totals, more than oftentimes the point and click will. And we can also run these over any 3-hour chunk of time. So from any 3-hour point to another 3-hour point, rather than just breaking it down into today, tonight, tomorrow, and the forecast periods that will show up in the point and click. And so we encourage you to use these as a resource as well. And some exciting news that we have to share is we're also getting our Instagram account back. Early next month is when that's expected. So if you find us on Instagram, we encourage you to give us a follow, and we'll be posting this kind of stuff to that account as well as to our Facebook and Twitter. And that's kind of the fourth way that we try and communicate the forecast. Feel free to engage with us, reply. We try and reply to people as much as we can to answer questions in the comments and the replies. So that's kind of what we've got for social media. And then the one thing I also wanted to discuss is resources. So all those resources that we discussed at the beginning, we're going to be sending out a PDF resource list of everything that we discussed, as well as a few more sites. That'll come to your email if you signed up for this clinic sometime in the next week, most likely. And then you're always welcome to give us a call or send us an email at the Weather Service. We're a 24/7, 365 operation, so we'll always pick up the phone. And I'll have our number here on the last slide. And then just kind of general advice for using all the data. Think about the forecast funnel. Try and think about how we've thought about the forecast and start your interpretation of the forecast in that way as well. Think about things on the large scale, what's happening in Alaska as a whole, and then what's happening on the scale of where you're trying to go skiing or snow machining or recreating in the mountains. And a good place to start too is the forecast discussion to get an understanding of the pattern and be able to kind of narrow it down with eventually the point and click and then observations from sites like MesoWest, Webcams, and 24-hour trends. So I guess those are kind of our parting words. Ed, if you want to say anything else to that avail, or we're happy to take questions at this point. Here's our contact information. Feel free to give us a call or send us an email at any point, or contact us on social media.
Yeah, thanks, Jonathan. There was one request to get the slides too. If we share that PDF, if we can also maybe do a slide, show the slides.
Yeah, that should absolutely be doable.
And then I have another question. Kind of, do you find certain models to provide more accurate wind forecasts?
Yeah. So higher resolution models are going to do better with wind simply because they can resolve terrain better in Alaska, and terrain is a big part of the forecast. We know that, for example, the North American model, the NAM, generally does pretty well with winds. However, the NAM can also be very out of line. I'd say between the NAM, the GFS, and the ECMWF, the NAM is more frequently out to lunch, as we would say, or doing something completely different from the other models. And so while it's generally pretty good with winds, it can also be very different. And so that's kind of the caution that we use with the NAM. High resolution nested models, the NAM has a 3-kilometer nest that can sometimes do pretty well with winds, especially through terrain and in northern Alaska. Generally, models like the GFS and the ECMWF are going to overdo winds in valleys, especially in the interior. Their boundary layer physics are such that they provide too much mixing. And so in the wintertime, that's part of the reason why we often have to knock down the winds in the interior valleys and then in turn bump down the temperatures as well, because with temperature inversions forming with light winds, less mixing is going to mean a stronger inversion in colder temperatures. So that's kind of a general overview of model biases with wind, I would say.
Great. I just want to take a minute. We had somewhere upwards of 80 participants, so we really appreciate that. We're down to 60 or so as the time went on, which is totally understandable. I just want to take a moment to thank both Jonathan and Ed for participating tonight. We'll certainly keep the lines open for questions. Folks have the ability to unmute themselves at the moment. So I believe, if I'm not a Zoom whiz, but I think I've enabled that at the moment. And then again, I would encourage folks to check out alaskasnow.org. One of our board members did a little bit of website wizardry this week and created a pretty nice weather spot just for that area there. So you can click on a couple of the more popular weather stations and get some information. I've got one nerdy question from the point and click weather side of things. When you're saying like 40% chance of rain or 40% chance of snow, 40% chance that it like might rain at all, or might 40% of that surface area will get hit by rain? Or
that's going to be a 40% probability that's going to rain at a certain point. So not necessarily 40% coverage, but a 40% probability that precipitation will fall in a certain time frame. So a 3-hour forecast might have a 40% chance of rain in that 3-hour time frame, but there might be an 80% chance that it's going to fall in a 6 or 12-hour time frame.
Okay. And then we had a question about Look Erie Basin, the site, and it looks like Philip's answering that it's a very wind sheltered basin. In my experience, it generally over predicts snow at the 5,000 elevation band. So the Look Erie station was put in the spot where it's going to show the most snow and the least wind. And we successfully did that last year where we buried the snow telecenter. Yeah.
I'm going to exit out of the presentation and pull up the chat so I can see some questions here.
Yeah, I'm going back through the chat here to see if
a lot of thank you here at the end.
Yeah, is there anything we missed? Okay, any last minute questions? Oh, somebody asked. Yeah, go ahead.
Will changing like northern sea ice, especially sea ice being up against the northern coast of Alaska, will that change weather patterns and snowfall in interior Alaska and in the Alaska Range?
Is this Philip asking that?
Yeah, it's Philip.
Yeah. I mean, I've definitely seen that over just forecasting the last 20 plus years. Definitely dramatic changes. Just with less sea ice out over the Bering and then even into the Chukchi Sea, it really changes the storm track and the weather patterns, especially in the middle of the winter when normally the Bering Sea would be, or the northern half would be ice covered. So yeah, just from my experience of observing the weather for a few decades, I definitely have seen changes. And especially it allows for a lot warmer, moisture air to kind of move up into the interior off the Bering Sea in the middle of the winter.
Cool, thank you.
But as for exactly the changes, I'm not sure. You know, adding that warm heat source is going to have impacts on sort of the overall global pattern too, especially with warming. You know, if you look over towards the Atlantic side as well, will change the sort of hemispheric pattern across the globe.
Looks like we got a question in the chat about how accurate are sounding or skew T forecasts, and to what degree time frame do we start to lose certainty with these forecasts? That's a good question.
Good question. I don't often look at. Is that Andreas? Yeah. Not sure where you sound pretty weather savvy. Where are you looking to get your skew T forecasts for? Anchorage. Oh, okay. Paragliding, Chugach range. Oh. I'm not sure. Yeah, Andres, I haven't paid that close of attention to, if I'm looking at a skew T forecast, how that pans out in an actual observation when that time frame occurs. Except possibly when we're maybe going to have a freezing rain event and we're very concerned about the depth of warm air and the possibility of freezing rain.
Yeah, that's definitely the situation when we're going to spend more time looking at skew T sounding forecasts. When forecasts talk about teleconnection, can you talk about downstream effects of the weather? So I think what this question might be about is kind of, if a model is showing one solution that we don't think is probable, the solution later on in time might also not be as probable. So I think when forecasters talk about teleconnection, it's more about how is the model solution impacting, how is a short-term model solution impacting the long-term model solutions. So maybe there's significantly higher pressure over the interior than all the models are resolving. And so the teleconnection with that would probably, in the wintertime, would be slower burn off of the inversion as a weather system would come in. I guess that would kind of be my example of discussing teleconnection.
And I don't know if you missed it in there, but there was a question about if you wished you were in a forecasting center that was much more predictable and a smaller surface area or service area and a lot more data. Are you, do you like the variety that Fairbanks offers, or do you wish you had an easier job?
It makes you a really good meteorologist forecasting up here. I guess is
sometimes you don't even know if you're wrong because we don't have observations. So yeah, I personally enjoy it here. Just it's a lot of variety, and then kind of back to Philip's question with the sea ice. Just you can't even rely now back on institutional knowledge you've gained over years and years because what's used to be normal is maybe not normal anymore, just because patterns are changing and we're seeing such dramatic shifts in the sea ice and then changes in the weather, especially on the western half of Alaska and Arctic.
We got one last question here from Ayal. If you guys can see that.
Okay.
What tools do you recommend for getting an idea about the weather? Heavy snow above warm temps a week out. What's the trend? Is the weather discussion what you would suggest? Anything else? The area forecast discussion is a good place to go. The other thing, I'll actually throw it in the chat right now for you, Al, that I'll look at too when I come in. If I'm doing the extended forecast, the National Weather Service actually has, it's called the Weather Prediction Center, which does kind of helps us get a better idea of what's going on with days 4 through 7, and they produce an Alaska discussion every day. So I just put that in the chat there for you. This is updated, and this will kind of talk about the models that they think are doing well with the extended. And usually, as the extended forecaster here in Fairbanks, we're going to try and reflect that. We're going to go with the same models that they're thinking, because they're spending their entire day looking through extended guidance.
Yeah. So yeah, which we don't have time. We're more focused on sort of what's currently happening over the next few days, and so it's really helpful to have the folks at the Weather Prediction Center to analyze the models 5-7 days out.
Yeah, that discussion is a very good resource.
Sometimes it's kind of nerdy and geeky, though. Depending on the forecast.
Glad you're willing to admit that.
The main consumer. Yeah, the main consumer of this discussion is the forecaster, so it's definitely geared toward us at the office, but it's public, so take advantage of it. Question here: do you normally highlight the Tanana Valley Jet? What signs could I look for in a forecast that might signal a Tanana Valley Jet in the central eastern interior is otherwise quiet? Probably the east winds at Delta.
Yeah, and often, gosh, I'm trying to think. We may not use that term in the forecast discussion very often. Yeah, that's a good question.
That is.
We usually, the result of us with the Tanana Valley Jet is we usually end up putting a wind advisory out for basically from Delta, in the Delta area, for easterly winds or southeast winds. I think that question, I think most people wouldn't know what we're talking about if we talked about a Tanana Valley Jet. I'm not sure if there's in any research anywhere, but good question.
Yeah, no kidding.
You guys see the last two there, and then we'll maybe wrap it up.
Sure. I'll let you take the top question, Ed.
Okay, there's a short-term snowfall forecast. Thompson. Yeah, and I don't know okay, Bob, for your there's a short-term snowfall forecast for turning in Thompson and Hatcher. Any chance of eastern Alaska range getting included in that? So I don't know specifically which short-term forecast you're talking about. I know our weather forecast office down in Anchorage works with the avalanche centers and does provide a product to them. We don't currently do that because we don't have avalanche forecasters providing forecasts for the eastern Alaska range. So I'm not sure if that's where you're headed or if that's addressing your question or not. So I guess the answer would be no at this point.
Yeah, that was my question. I guess for future, once at some point there's more consistent forecasting for the eastern Alaska range, then potentially because it's snowfall forecasting. Yeah.
So we because the Anchorage office will issue their rec forecast with specific, I think, elevation and snow and other temperatures at different elevations. And so, like I said, we're not doing that now, but I know if Eastern Alaska Range at one point wants to start getting our forecast for the Eastern Alaska Range. That's something we could provide for here. You want to get the next one then, Jonathan?
Yeah. How common are occluded fronts during the winter? I guess that is kind of a tough question. I would say they're more common out on the West Coast than they are in the interior. Commonly in the interior, you'll get kind of we often talk about the Arctic front. How far south is the Arctic front going to get? Which often moves farther south in the wintertime than it does in the summertime. Other than that, I don't know that there's a general trend in terms of the prevalence of cold, warm, and occluded fronts by season. I mean, obviously, if you get a big low pressure system moving into the Bering Sea, it's going to move north. It's going to throw a cold front into the western interior. There's going to be a warm front kind of on the north side of that, and then as it moves north, it's going to occlude. So I'd say that's probably the most common setup for an occluded front in Alaska, or at least in northern Alaska.
Okay. Looks like Sebastian, you asked, what are the best resources for looking to ski in the Cantwell, Healy areas? Is that more in the Anchorage office domain? So our office here in Fairbanks, we forecast down to just north of Healy, just north of Cantwell. So Cantwell is actually in our Anchorage forecast area of responsibility. But north of there, like Denali Park and Healy is our area. And a lot of what I talked about in the Eastern Alaska Range, many of those weather patterns apply and are similar over in the Cantwell-Healy area as well. That's the other nice break in the range where you've got a good pass that goes all the way through. And so you have very similar patterns in both locations.
Then we got one more question. Is the new GOES satellite helping models yet? I think that the answer to that would be yes. I mean, the new GOES satellite is being ingested into models. Up here in Alaska, we definitely rely more on polar orbiting satellites than GOES, just because they're much higher resolution. So I guess to that question, I would say that it is helping models, but the satellite ingest is also just one piece. And especially with surface parameters, models finding ways for to improve model surface parameters is going to help models help make models better, even in addition to new GOES satellite imagery.
Well, again, I want to thank Jonathan and Ed for your service tonight. I appreciate the time you put into this. We've been working on this for a while, and I think with 80 plus people showing up, it shows that Zoom education is doable on a Thursday night during presidential season. So I appreciate that. Again, I encourage folks to go to alaskasnow.org to check out the different regional avalanche centers. You can choose to support us there, the Eastern Alaska Range Avalanche Center, or the AAIC as a whole. And then, but also I encourage you to go there and share your observations. If you're going down to the Eastern Alaska Range, snow machining, skiing, snowshoeing, what have you, you can get in there and create a quick post about what you saw Did you see shooting cracks, a bunch of snow, wind, what have you? It doesn't have to be scientific. You can break it down, throw up a picture, and that's helpful for somebody else going down the next week, just to get an understanding so that they're making a little bit more of an educated decision before they head out. And yeah, that's all we have for tonight. I appreciate everybody. I'm not going to tell you who to vote for, but get out and vote. And we'll see folks. We'll probably do this again. I think it was a huge success, so we'll continue it on and maybe kind of distill it down to a maybe a different style or something next time.
Okay, thanks, Mark. Thanks, Philip.
Yeah, thanks, Mark and Philip, for setting this up, and thanks to everyone for attending.
Yeah.
Yeah, thanks everyone.
Yeah, huge help. Thanks to those that donated in the Eventbrite as well. Much appreciated. That'll build us another weather station. Help these guys do their job.
Okay, see you guys.